Everyone for joining us today. Super excited to have all of you here. So welcome to the Big Sky Standards Real World Data webinar series. Today we're going to be discussing why data science. So super excited to have you here. First, I would love to introduce to you to your wonderful hosts. I'm Samantha Leave. I'm the Director of Policy for Data Science for Everyone. I'm just super excited to be here. I assist different state educational agencies with implementing data science. I'm most excited about data science education K through 12 because I feel like in mathematics, there's not always a lot for students to get excited about, but once it clicks for them with data science, it really clicks and they kind of just run with it. And that's just one of the most exciting things for me. Lee Ellen?
Hi there. I'm Lee-Ellen Harmer. I am the Partnerships Manager for Data Science for Everyone, and I am really excited to be here. I often guide districts in implementations or discovering how they might implement data science in their classrooms. And I also help manage our content partner network with folks who offer resources for data literacy and data science. And I am most interested about delving into data science across K-12 because I feel like it really empowers students to be able to use data as they represent their voice in discussions and help to build their case in claims that they're making. So really excited to talk with all of you today. And I'll pass it off to Katrina.
I'm Katrina Ingledrum. I am OPI's Math Instructional Coordinator, and I am partnering with Data Science for Everyone as the OPI representative to bring you all this training and make that connection to those standards that so many of you referenced as your interest in being here.
And I am Amy Conzen. I'm the Professional Learning Manager for the OPI, and I have had the pleasure of working with these women and getting ready for this event and just learning alongside of you and helping to support the implementation of the new standards. And making this content accessible for everyone has been one of our goals from the beginning, and I'm excited to show you what they've worked on.
Sorry, I muted myself and then forgot. Diving right in, I bet you guys have this basic question that we all want an answer to, which is what exactly is data literacy and data science? So Lee Ellen's is going to talk a little bit more about that.
Yes. So, Data Science for Everyone has created some definitions that we thought would help to explain the difference between data literacy and data science. Data literacy, in our definition, refers to the ability to read, understand, interpret, and communicate data or claims derived from data. So it involves teaching students how to critically evaluate data, including understanding its origins and its limitations and potential biases. It also involves teaching students how to effectively communicate data through visualizations and other means. And some of those words feel a little technical, but this can be done across many different grade levels, including our youngest students, and really helping them to understand what are these pieces of data and how do we talk about it and how do we look at visualizations that represent that data. So data literacy is more that foundational level of working with data. If we move on to data science, here we go. Data science education refers to instruction focused on systematic processes, analytical techniques, and utilization of appropriate technologies to gain knowledge from data. It involves teaching students how to use tools and methods across the curriculum to collect or consider, analyze, interpret, and communicate data to answer investigative questions. So you can see that data science really takes that a step further. We're no longer just looking at data and visualizations and making claims and communicating about it. Now we're really using these systematic processes, these analytical techniques, And we're really diving into the data and truly understanding what it's trying to tell us. So we're getting more into that deeper level manipulation of the data and understanding what it means exactly. So with that, we're going to talk a little bit about how data comes into play in industries. I'm going to turn it back to Sam.
Some of you might be thinking, does this mean we're trying to train our students to be data scientists? And the question is no. We believe that data skills are really crucial for any industry and any jobs that our students might pursue. And so this was actually pulled right here in Montana. It was the 31 hot Montana jobs for 2025. And these are just the top 10 that I had pulled for you guys to look at. Even though some of these you might not think are associated with data, the skills that are needed in order to have some of these positions are data skills, right? So a marketing manager is going to have to collect data and then also analyze that data so that they can make good decisions for whatever market they're working with. Customer experience strategies, you want to make sure your customers are enjoying whatever services you're providing. So that again is these data analytical skills. So these are just one reports showing how data can be connected to Montana in particular. This is also just kind of the demand, the workforce industry demand here in Montana. If you guys notice, some of the bigger players here, like agriculture, retail, wholesale trade, these are sometimes positions that are not always thought of as connecting to data. And so this is kind of what it looks like in Montana in particular. But if you look at this, and if your screen's small, this will zoom out. This is actually a report that was pulled of all of the job postings that were available in the industries and what skills were actually asked as prerequisites. And a lot of them actually had data analytics skills. And so if you notice, this graph is actually for Montana in particular, but arts, entertainment, and recreation is not always an area that we're thinking is connected to data skills. And they're actually one of the top areas that are asking for those. Retail trade, finance and insurance, transportation, warehouse. So there is a really strong need for our students to have these skills and not having to pursue a data science career. We really see the benefits for our students here. And that leads us to why are we here?
All right, so many of you mentioned in the earlier chat that you're here to learn about how data science pulls up in the new standards, and that's my domain, so I'm here to share that with each of you. So to kick us off, oops, Sam, it's not really working for
I
my...
know it froze for me, and I can't change this part
Okay,
here.
well, while we're waiting for the technology to catch up to us, I'll share what the timeline is. So some of you, I see some familiar names on here and faces I know are very familiar with this, but those of you that may not be, I'm just going to share that we're setting new standards to be implemented in July 2026. The Board of Public Ed has already approved those standards, and we're right in the middle of offering PD and guidance documents to support teachers with the work ahead. This process started all the way back in 2022, and it was really created through the work of Montana educators because we had many task force people involved who are both current and recently retired educators across the state, as well as some family members representation, tribal representation involved in this work. So this really is a collective Montana community effort to bring new standards to classrooms and to students. Thanks for that, Sam. So again, that date is July 2026 that we're setting for implementation. And it is not letting me click still. Oh, there we go. Okay. Why? Why did we change? I think that's the number one question that we get from teachers. They want to know why we needed a change. And I think this webinar provides a perfect answer to that, is that data science was not as prevalent in 2011 when the standards were previously written and released as they are now. Lee Ellen and Sam created those beautiful slides that showed you how much the demand in the job force has gone up with this in mind. And if you're interested in further research, there are two handouts that are relevant to this specific conversation that we're having that were prepared by the REL, which is the Regional Education Laboratory. They work with the Department of Education. And they created a summary of research that is happening across the country and world in these areas. So the first one I'll call your attention to is REL Handout A. You can, if you have the copy of the slides, I don't know if we dropped those in the link for people to see, but you can also access this on our website. It is available. That handout specifically focuses on early learning and elementary topics. And within that, they identify data as a foundational concept for our PK5 students that helps them build success throughout their journey in education. They also identified that young students are able to work with and understand data, which has not always been a thought that many people have had, but they are capable of understanding those kind of groupings and how data shows up and how it translates to their classroom experience and their world experience. The last handout that I'm going to call out is REL Handout C, and this is more that secondary focus. Why did I skip B? Well, there's another one that's not really pertinent to the conversation today, but that's a great one too. You should read it. Handout C covers all the secondary topics. So this is where we see a lot more kind of career focus results. They noticed within that handout that data science and analysis were the second most rated technical skills missing in applicants. So we're seeing in the workforce that students are really lacking these abilities. Many jobs require students to work with data, even traditional careers like nursing and teaching that maybe didn't have as much over-reliance on it before are becoming more and more necessary skills in those fields, in addition to modern careers like AI. Yes, Heidi, I agree. They are very foundational skills for AI. Thank you for pointing that out. I agree entirely. And so that's why that's another thing that was mentioned in handout C as well. And then that handout also advocated for flexible four-year pathways, so broadening from that typical calculus pathway to increase opportunities for students to engage in things like Intro to Data Science or statistics courses. They also, I think this is the most important part that I read, was that they're showing that students who have access to those courses tend to have increased confidence, empowerment, and belonging, which is why we're all here anyway, is for the students. So it's great to see that those courses increase those outcomes for our kids. Okay. It doesn't let me click back, Sam. There we go. Thank you. Technology is fun. Okay, so the next question that teachers typically ask is, what does that mean for me and my practice? We have a couple bullet points. I won't read them all to you because I know that you can read yourselves, but I'll call out some of the most important ones. We need diverse pathways for schools and for students. So that's an important one. If you're not offering any kind of opportunity for students to work with data in your school, especially in that high school setting, you're going to want to look at how those opportunities can be provided. Districts will need to critically evaluate their curriculum to make sure that there's opportunity to align with those new standards within the coursework that they provide. PD can be offered that would support schools and teachers. And then the last one is that educators can really model their own data literacy. I think as teachers, many of us use this in the classroom every time we take an assessment for students, right? So modeling that we do make data-driven decisions and how it impacts our lives is going to give importance to students. And then with learning, this is really all about students' implications in their instructional exposure. So we want students to be able to collect, analyze, interpret, and present data. This is going to help them be more informed citizens, which is going to hopefully strengthen our whole society as a result. This is going to help them explore data in age-appropriate contexts that scale up and continue to foster their learning all the way through their experience. And hopefully provide them opportunities to explore data through issues that are relevant to their communities and make them stronger and more actively engaged community members. I'm curious, before we move on, if you all can drop in the chat one thing that you think you're maybe excited about for an implication on teaching or learning from these new standards. Ooh, Heidi, that's cool. I'll have to check that out. Thanks for sharing. Claire, great comment. Yep, this offers a lot of opportunity for us to work across content areas, which it's like you knew what was happening here because Lee Ellen and Sam will be covering that later in this series as well. I agree, Julie. This is going to give a lot of 21st century skills to students. Thank you for those of you that were able to share. We're going to move on. You can keep dropping those in the comments, especially if you haven't gotten there yet. But I do want to cover some of the shifts that you'll see. So we have a lot of standards at the content level, and we don't really have a lot of time to go through every single grade level. We will explore all of those in the math implementation webinar, which if you're not familiar with, maybe Eva, you can drop the chat in the link for people to register for that one, where we'll do a deep dive on those standards. But one that hits K-12 and honestly even PK-12 is our practice standards. So that's what we're going to cover today. Those have changed significantly. So on the screen right now, you see our first new mathematical practice standard. This is problem solve and persevere. You will probably notice right off the bat that this is a little different than what we had previously, but I want to clarify how this shows up in data science. So an example is a community data set that's being explored. In my community, I live by the river. I have a dam that's owned by the tribe at this community, and we would look at some of the water flows that would happen and the data associated with that coming out of the dam and maybe some energy levels that are a result of that. And we would make conjectures as a classroom to try to test through graphs and refine our strategies to figure out what those results of the conjectures are and if we were correct or not. The second mathematical practice is to abstract and generalize. So in the context of data, this might look like forming from a table of school garden plant growth measurements. Students might develop formulas or functions that model trends that would absolutely require them to abstract and generalize, taking a contextual situation and make it into a mathematical one. Justifying and proving, we might see students examine graphs from various sources and look at bias or inaccurate representations. There's a bunch of those out there. You can probably pull one from a single magazine or newspaper and find one. And if you're interested in exploring that further, the New York Times has a great database of those that you can look at and pull right from their website. Model with mathematics, we might see this mathematical practice show up with students exploring contexts that they are interested in further. So they might collect, this is an elementary example, shadow lengths over multiple hours, build a ratio model, and use that to approximate the height of objects and understand proportional relationships. We might see them represent. That happens so much with data because of all of the graphs that are present. So there's a natural alignment with that. And I think the key point in this new mathematical practice is understanding how those representations are connected and how you can translate from one representation to another. So raw data set in a table to a graph and how adjusting certain variables or aggregating the data might adjust that graph is important. The example we have here is displaying it in multiple forms, comparing the appropriateness and choosing the best for specific audiences and contexts. And then the last two mathematical practices are collaborate mathematically and culturally connect. With collaboration, students might consider problems that can be solved by data and work together to evaluate those problems. Culturally connect, learners might work with a tribal community data, such as tracking a local animal crossing. Shout out to Michelle. There's a course on the Hub that if you want to learn how to do that with your students is available. They might also look at that data from the dam energy outputs, like I shared earlier, and discuss findings in a cultural context. So hopefully that gives you a brief overview of some of the ways that data shows up for us. In summary, these mathematical practice standards can be used as methods for strengthening data literacy and analysis in students. We have all of these opportunities to use modeling, justifying, improving, representing, and oftentimes in data, it involves more than just one. I'm sure you saw some of those examples and went, wait a minute, I see representing in that abstracting and generalizing example. So you can see a lot of them. Thanks, Heidi. I also love the local representation, and that is an important point in our new standards. We have a lot of them indicate that there needs to be a local cultural context or an Indigenous context in those standards. So that's why we've emphasized that a lot, especially that cultural connections piece with the mathematical practice. Before we move on, I'm wondering if we can share one idea that you have for how these mathematical practices can show up in your classroom or in a classroom within data. Heidi, I'm glad you called out the patterns. We didn't mention that specifically, but pattern identification is so important, especially to that abstracting and generalizing mathematical practice. Julie, I like that you mentioned both tables and graphs because it is so important that students get exposure to both opportunities. And the local data does make it relevant to students. Jesse, I agree. These can definitely help that critical thinking skills, those critical thinking skills. Yeah, Carrie, arguments, using the data to help form an argument. And that is an opportunity for that cross-curricular integration that Claire mentioned earlier in the chat. Well, great. Thank you everyone for the thoughtfulness and the wonderful responses. I agree. I think you all have great ideas of how this can show up, and I'm excited to hear how this happens in classrooms across Montana. I'm going to pass it on to our next speaker.
Great. So I feel like you all have kind of made this last slide or this next slide very easy for me. I'm still going to talk through this and talk through the implications of it. But as we talk about threading data into the curriculum, Data Science for Everyone has developed some, you could kind of think of them as best practices, but we call them data science starter concepts. If you feel like you're a little bit overwhelmed of how do I do this work? How do I bring more data skills into my classroom? We have developed these 5 concepts that can really help you do that. And it's, it's something that you're probably already doing just from some of the examples I've seen in the chat. I think a lot of this will not be brand new to you, and it's really a matter of how do we go a little bit deeper and help students move from sort of that data literacy over to that data science and more the technical approach and really diving deeper into this work. So the first best practice is telling stories that matter. So this is all about using data to communicate clearly and persuasively while being honest about what the evidence can and cannot tell us. So you're doing this by helping students support arguments with evidence in writing. I think we heard about that just a moment ago in the chat. Creating presentations about research projects, discussing why graphs needs titles and labels that help readers understand the graphs, and talking about considering your audience when sharing information. I know that one was touched on as well. You know, how do we tell that story given our audience? We may tell that story a little bit differently if we're talking to our classmate as a student versus if we're presenting it to a parent or a teacher or an administrator. And so helping them understand how you tell that story. And then guiding students to explain why should you care about this. So this is actually the number one skill that data science educators identified as being the most important. It's the the ability to craft compelling, honest narratives with data. And students need to move beyond just making charts to actually telling stories that can change minds and inspire action, which is really exciting. How do we help them feel more invested in that data and telling that story? So the next starter concept is questioning everything. We want students to have a healthy skepticism about data claims while learning to spot when analyses might mislead, exaggerate, or misrepresent reality. We also saw this in the chat. So again, you all, I'm just reinforcing everything that you all have already said, and I appreciate that you already have such a great handle on how this can be brought into the classroom. So how do we help students evaluate sources in research projects? Teaching them to ask what's missing from this picture. I think that's a really nice piece to look at is with our information heavy world, our data heavy world, they come across so many different data claims. And we need to really teach them to say, how do we know this? And what else might explain this pattern or who benefits from this conclusion? So not just taking it at face value, but really diving into it and understanding the why and the how and the what's next. The third one is making it real. So how do we connect data skills to daily life decisions and understanding the ethical implications of how data affects real people? I know this is a big piece that I think we hear surfaced a lot, even in those discussions with AI, but it's really important to know that this is that very foundational piece when we're talking about data literacy and data science, that we want to look at that ethical piece. What kind of data was collected? What are the sources? Discuss the privacy and digital citizenship of that data. Talk about the fairness and representation in those classroom activities. And then really connecting to students' communities and their lived experiences. So this is very important. And it's something that we can go beyond just sort of asking the surface level questions about the data and really getting into some harder questions like whose lives could be affected by decisions made with this information, and how could we collect this data or use this data more fairly. So then that kind of leads into the fourth starter concept, which is asking better questions. So how do we move from just I wonder to I wonder, and here's how we could find out with evidence, and being comfortable with some uncertainty for students. So we can help students do this by turning observations into testable questions during science experiments, for example, guiding them to be more specific rather than vague in their inquiries. And then look at it in probability, even in everyday situations, like will it probably rain or are we likely to finish on time? So helping them to really understand what is the evidence behind some of these concepts. And then not only, again, we're sort of moving into that deeper level of questioning and going from, why is this to what could we do to count or measure or compare to explore this? So how could we not just research, but how could we actually collect some data to answer these questions? And then finally, there is this idea of working with complex information. So understanding that real world data comes in many forms. It's not always clean. It's often messy. And so how do we help them get comfortable with the messiness of that data and help them to see how they organize data that comes from different sources and how they work with different types of evidence, whether that be quantitative or qualitative, and helping them use different digital tools, for example. So I think this is important because, again, often we present data to our students that is sort of nicely arranged in these tables and graphs, and we want them to get comfortable with the kind of data that they might see when they're going out to do this discovery work. And they may see some messy data. That's what it looks like in real life. So starting to get them comfortable with that. It doesn't mean it has to be messy every time, but getting them used to that process. So these starter concepts, you've probably already noticed they build on each other. And it's a really nice way to help students kind of work through these different stages of working with data. And these are concepts that we're going to continue to revisit throughout the different webinars that we're going to be hosting. And we're going to be applying these through the different sessions to help you see what that can look like in the different topics that we're exploring over the next several months. So with that, we are going to dive into a classroom example, and I want you to kind of keep these ideas in mind so that we can ask better questions, make it real, look at the ethical considerations in this example that we're about to see. And I'm going to toss it to Sam to go through that example.
Sorry, for some reason my Zoom menu didn't want to work with me. I would love for everyone to put on their investigator hat. We're going to be doing a little bit of investigation and to prepare you to be typing into the chat box. I'm going to give you guys a quick second to just get ready to observe and then also give us some questions, things you see. Super excited. As a previous classroom teacher, I was always, when sitting through professional development opportunities, it was always like, what does this look like in my classroom? What is the resource that I could pull right now and use and implement right away? So this classroom example hopefully gives you that. The first thing is this graph. So put your investigation hat on. Let me know, what do you notice? What do you wonder? What do you think this graph might be about? This is an activity that not only can you do with your peers, but also with students. Would love to hear in the chat or see what you guys are thinking. I'm going to read the comments for those of you that are typing. Brent said similar trends among all three sets. Katrina says she sees 4 trend lines. I wonder what the time scale is and what is being tracked. Brooke, I wonder what they are tracking. Michelle, what are the X and Y? Heidi, 2 dips down. Sorry, the chat's moving so fast. You guys are so quick. Let's see. 2 dips down is the blue of trending up. All 3 lines trend down overall with a short rise. The bottom one stays consistent. What are the different trend lines? What are they tracking? I love these questions. So I'm going to pause really quickly there. I want you to notice that all of us are on varying skills of mathematics. And so every single student had the opportunity to provide some type of answer. And so this is really accessible to every single student, regardless of how confident they are with their mathematics abilities and skills. So that was something that was really important to us. So I love these questions. Keep those in mind, and then also your investigation hat still on. Do your questions change, or how do you build on those questions with this additional information? So, what new information did you just learn? Is this going to change your thinking? Does this give you more context of what it might be about? What do you think it might be about? I love that. It's a quantity, but of what? I love these assumptions so far, right? Population, maybe, right? There's a timeline. Ooh, I even love connecting it maybe to different towns or cities or school. Maybe we're thinking of what each one of these trend lines is. Potential demographics, love these. I love this so far. So we're going to continue on. I love that answer. Also wish this was the cost of housing. You'll get those really creative students, and sometimes those out of the box ideas are fantastic. It strikes these wonderful conversations. Also love income. So we're going to move forward just a little bit. And if you didn't notice, now we've added on some labels. So what information did we just learn? How is this helpful? Connecting it to a different content area, such as agriculture, right? What are we harvesting? Just to make sure we finish on time with you guys, I do want to go a little bit quicker. So now we have what these trend lines are. We have a little bit of a legend on the bottom. Great question, Katrina. What happened in 2014? I love that the Y and X axes are needed in order to understand. They're really important, right? I also have a random question of, well, does every student know what a buck or a doe or a fawn is? I didn't grow up in the country, so I honestly wouldn't have known. So now we've got the title. The legend's on the bottom down here underneath the years. It's kind of hard to see. Yeah. Now we can have tons of other questions that are related to this, right? So your students might know if they live in a rural population or if they are hunters, right? And then Heidi had a great question of how did the number of hunters correlate to this data? There's so many other questions that could build off of this. I love that your students could see the connection between this, right? Orange is the total harvest, blue is bucks, gray is does, and the light blue is the fawns. Oops. So after seeing this total graph, now that you're seeing it holistically, what questions do you think you might still have that this graph maybe doesn't answer? So when Heidi had a really great one of like, how do the numbers of hunters correlate? That's not in this, but could that affect this graph? Yeah. What are some other maybe questions that you might have that just are left unanswered? Yeah, why are the bucks higher? I love that question, Jesse. What about is this graph related to the reservations, right? Because this is coming from Montana. It's actually coming from your guys' DOE. Great question, Brooke. Who is tracking this data? I just mentioned that it's the not the DOE, the Department of Natural Resources. A lot of times we'll do population tracking. So I love these questions that you're asking because none of these questions are directly connected, or they are connected to this graph, but it's almost a wondering. And think of how many different branches your students can now go research and go look for information, additional data to support it. We're also thinking of the ethics behind it, right? So the data that's included, what are some of the missing pieces that maybe we're not considering? So just to answer some of those questions, this data that is represented in this graphic is actually just those that are reported to the Department of Natural Resources. And since that is a state agency, they actually don't collect any of the hunting data on the tribal reservations. So that's a huge chunk of information that's actually missing. Does that mean that this information is inaccurate? Then you can have that conversation of it's missing a huge chunk. So is this actually accurate information? Could we duplicate this information from state to state, right? This is local to Montana. Does it also follow or hold true if you're looking at a regional approach or a city, right? So there's all sorts of different data that is actually out there collected by different state agencies or regional agencies, and your students could really explore and answer some of those different questions. What's really nice is that who are the students that are gravitating towards this graph or this data that we might not usually connect with in mathematics? Students that are interested in agriculture or hunting, sometimes they don't see themselves in mathematics. And so giving them the opportunity to really see themselves gives them that chance to really connect with the material and then also build confidence within mathematics. So I love that we went through this. You guys had amazing questions and wonderings. This particular activity, if you are not familiar with it, is called a slow reveal graph. So you take a graph and you just present bits and pieces, and along the way, students get to explore maybe what they're thinking, what they see, question what's missing. And so the slow reveal graph has a website. It's linked below. We have all sorts of different resources. I do also want to mention that they don't have state-specific examples, but it's not very challenging to find a graph that's specific to Montana or your students' interests and then create something really similar. But they do have some really great resources and materials, and the link is there below. They also give you the different routine prompts, and just super exciting. So with that being said, we are wrapping up. And so we do want to give you guys the opportunity after our first session. What are some questions that maybe are still lingering with you that you'd like us to answer now, or maybe we'll even answer them later down the road? Oops. Do you guys have any questions? Heidi asked, will there be a session on data moves like sorting, filtering, and grouping? Leon, do you remember our list of topics? I can't remember them off the top of my head.
We'll grab that right now. I know that we are next. Our next webinar will be talking about specific resources by grade band. So we will be talking about resources for K-5 versus 6-8 and 9-12. And so we may get into a little bit of that resources that get into that. But while we look at some of the other questions, I'll circle back and let you know if some of our later sessions get into that level of detail.
Yeah, Katrina added the question, what kind of resources will people walk away with during these overall series? We look at it at a very holistic approach. So they could be one-off kind of activities like today that we presented that are very introductory. They could be larger projects. They could also be some sorry, just wanted to check the chat really quick. But some other curricular resources as well, like curriculum providers and what tools might be out there. Also, just kind of building your own confidence in providing instruction around data science and data literacy. We want to make sure that you guys feel comfortable and confident when you guys are providing that instruction. Also, just data analytics skills for assessing if your students are doing well in learning and mastering these skills.
Sam, did you see the question about curricula that incorporate these types of materials?
Um, Leon, do you know if any of the curriculum providers have incorporate slow reveal graphs? I know a lot of it is more of like a single off connection.
Yes, no, I don't believe our curriculum providers do, but I can. There is one session where we are going to get into a little bit, we're going to get a little deeper into the art of data visualizations, and we are going to highlight slow reveal graphs. There is an actual website where you can grab various slow reveal graphs based on topic or grade band. Um, but beyond that website, I don't believe our content providers pull those in necessarily.
Yeah, and this slow reveal website does have, additional like graphs like that we just demonstrated. And it's actually a really great resource. Somebody had mentioned in the chat earlier just the interdisciplinariness of data skills. And so if you want to even share that resource to your social studies, they have some great ones with, for example, populations and how they've moved during different time periods. There's also some really good science one. There's one about heartbeats on different animals. Just some really good resources there. So with that being said, we're just gonna wrap a few things up. So if you do have any other questions that you have, because we also understand that sometimes when you walk away, there's a spark that sometimes hit and you're like, oh, I've got this question. I wonder if they've got an answer for me. Contact us all at opicsi@montana.gov. Also, just so that you're aware, the timing, the scheduling was slightly off, but we are going to be having this webinar series on a regular basis. It is the second Tuesday of every month. And so our next one is going to be September 9th, and it's titled Take the Intimidation Out of Data Through Mathematics. Also, before you leave, in order to get your um, professional development hours, we would love for you to complete this feedback and evaluation. And to assist us next time, we would love to also have you fill out this poll on Zoom just to know what grade bands you guys are connected with the most. And then Katrina, Heidi had a question of, will these be housed on the OPI website, or is there a location to find these later?
Yep, I was just typing a response. So we can post some of the ones that were shared. The website can get murky. For those of you that are familiar with OPI's website, it's kind of hard to find things. So there is on the math standards page, which I'll link here as well. You can find a spot where we hold all of these kind of classroom level resources that are really great. It's housed on Padlet, and many of the ones that have been mentioned are listed in there. And we'll add some new ones that Heidi, for example, shared in this chat. Mm. Thank you everyone for joining us. I hope that this has been informative. This really is the introduction session, so I know some of you may have wanted to walk away with a lot more meat on the bones and a little more guidance that got a little deeper. We will do that across the series, but this was hopefully going to give you an overview so that you're set up for success throughout the rest of the webinars that we have planned. Yes, Sonia, we will house the slides and the recording on the OPI website. We did not already answer that, so I'm so glad that you asked that question. The next session was September 9th. Is that right, Leolyn?
Mhm.
Great. Okay, so September, same time, you will get an invitation to that one as well.
Yes, and you will, because you all are attendees and registered for this webinar, we'll have you on a distribution list. So we'll make sure that you're aware of any upcoming sessions. But as Sam said, it'll always, this was the exception, but going forward, it will always be the second Tuesday at 4 p.m. Mountain Time. And the next session is on September 9th. So we look forward to seeing you all there again.